Welcome to this video and audio introduction in the education curriculum product development in numerical systems and mathematics. The project and the program being developed is called Developed and Advanced Theoretical Methods in Learning Numerical Systems and Mathematics, a research and product development program by myself, Athanasios Kokontis. The following slides will present to you some information and some on this program, development program and project. And there's a 10-minute video introduction that's quite comprehensive, and it will give you an insight into the work, the objectives that were being developed and continue to be developed since the beginning of 2019.
Audio presentation and introduction to the independent research project, Developed and Advanced Theoretical Methods in Learning Numerical Systems and Mathematics. An independent research project by myself, Athanasios Kokontis, in Numerical Systems and Mathematics, an independent research project which I commenced in 2019, and which contains determined preconditions and defined objectives to increase the success rate for a student and individual achieving advanced mathematics, from my current estimate of a 30% success rate when considering current education curriculum and training methods, to now an 80% success rate. The 3 years of this independent research project was based on preconditions and defined objectives. The 80% success rate to be achieved is based on the following methods and objectives. 1. A well-researched and developed prerequisite numerical education system, which is a developed procedural learning method and process. 2. The primary objective the developed education system must achieve is the 80% success rate in a student achieving proficiency or advanced mathematics skills. 3. Defined preconditions that will increase the probability of achieving the 80% success rate. And 4. The methodology will incorporate some understanding of human cognitive reasoning function development methods. In effect, it is a standardized procedural learning and education system for curriculum in numerical systems and mathematics education. The education program comprises 2 key components. The first component reconstructs the current system of numbers and numerical systems, to better translate to the student or individual the correct interpretation of the numerical system in use today. And the second component applies the developed methodology of procedures and applied properties to number systems and mathematics topics. This procedural approach to numerical and mathematics education and training is innovative and advanced work by Athanasios Kokontis and is not based on current conventional curriculum or current textbooks used in arithmetic theory and mathematics education today. Current numerical and mathematics education today at all school level consists of a brief introduction to arithmetic theory and then jumps immediately to mathematics topics. This approach has been identified as being the incorrect procedure, which results in the current estimated low 30% success rate for an individual to achieve proficiency or advanced mathematics skills. The procedural system Athanasios Kokontis developed, Advanced Theoretical Methods in Learning Numerical Systems and Mathematics, makes it possible for the student and individual to obtain the correct understanding of the current number system and all applied mathematics topics. As a result, the process and methodology of acquiring numerical systems and mathematics skills according to Athanasios Kokontis is now corrected. Without a correct procedural process, and with the current curriculum continuing to be delivered in education programs in its present format, achieving advanced mathematics remains a difficult achievement for most individuals.
The research project has resulted in 5 subjects being developed and 5 volumes of knowledge which comprise the core curriculum and training program, developed and advanced theoretical methods in learning numerical systems and mathematics. The first topics will reconstruct the number system, the second and third will introduce the developed numerical and number system procedures and properties, and the fourth and fifth volumes will apply the developed procedural methods to all mathematics topics to prove that this is the correct education approach and method.
I now will introduce the important defined preconditions for this audio presentation.
In order to achieve the 80% success rate, the procedural education process will require to achieve the following preconditions.
Increasing an individual's capabilities in order to reach the proficiency required to achieve a comprehensive understanding of all mathematics topics. By way of B. Developing a comprehensive procedural numerical system and number theory course used in the field of numbers, mathematics, and metrics today. And C. The developed system will be applied to all mathematics topics to prove its corrected approach to mathematics. And D. The system and curriculum must be developed as a procedural learning and standardized theoretical learning approach in mathematics curriculum. In order to achieve E. Proficiency in high-level mathematics, with a minimum 80% success rate for any individual who completes the course. And the completion of the course will result in F. Retention of the knowledge obtained by any individual, with the requirement for only revision to recommence studies or the use of the acquired new numerical and mathematics skills. And with successful retention of the knowledge by individuals. G. This would be confirmed as the correct curriculum procedure of obtaining the proficiency skill level requirements and learning of numerical systems, number theory, and all mathematics subjects. I will now discuss cognitive reasoning function benefits identified. The following are some brief comments about the identified and probable cognitive reasoning function benefits for the human who completes or learns a comprehensive procedural numerical system as this one. It was determined in year 2 of the project. In the year 2020, this procedural education system may have a cognitive reasoning benefit for people with low IQ or disability. What was strategized and envisioned in the second year of the research project was to reconstruct human procedural learning processing and thought processes for learning and using number systems, with consideration to human cognitive functions. This assumption and strategy opened in future applicable science to cognitive reasoning development made possible by a perfect procedural process. And the assumption was that standardized procedures will allow the numerical system to be learned with minimal difficulty by the human or the individual, and if this was true, then the procedural system would be correct. In the following comments I explain how cognitive reasoning benefits are obtained. The current education methodology used in education today, as discussed above, comprises a brief introduction to arithmetic theory and then immediately jumping between topics of numbers and formulas and equations contained in mathematics topics, which results in the low estimated 30% success rate. Without procedure in place, and the attempt to learn a volume of knowledge that's not organized and not procedural, the human brain cognitively is not able to comprehend such variation in complex numerical and mathematics topics, but if you give the brain of the human procedures and a sequence of procedures, it then automatically will achieve the understanding of the volume of knowledge of topic. For example, like counting 1 to 10, this is a sequential standardized procedure in counting quantities, which we can confirm children can learn and people with lower IQs and disability are currently achieving. This understanding in fact also confirms that a procedure of learning mathematics will result in a higher success rate. As a result of this preliminary finding, a second independent research and development project will be considered, with invitations to neuroscientist professionals to participate in this effort, with the primary objective to prove that the procedural numerical learning system developed is an applicable science and system which can assist with an individual's cognitive reasoning development and IQ development. Athanasios Kokontis states that this finding and unplanned consideration in applying the procedural learning system to cognitive reasoning functional development was unexpected and will be considered the reward to the entire outcome of the project and will be a second achievement should it successfully become an applicable and beneficial science in human cognitive reasoning development and IQ development. Thank you for listening to this brief introduction to developed and advanced theoretical methods in learning numerical systems and mathematics.